to the video here for lesson number 7, coordinate proofs using quadrilaterals. So the opening exercise is kind of us just going over the 5 different shapes that we can eventually prove in these proofs that we're going to do over the next couple lessons here. So if we were in class, I'd say try the opening exercise, state a characteristic that makes this shape special. So go ahead, pause the video, and try and write down some characteristics of these 5 different quadrilaterals. All right, so let's see how you did. So for trapezoid, what I would say for trapezoid is it has one set of parallel sides. To prove that, we're going to use slope. So to prove parallel, all we have to do is show that 2 slopes are the same. Parallelogram had 5 different traits, but the main one was it has 2 sets of parallel sides. Again, we would use slope here. A rhombus is just a parallelogram with congruent sides. That we're going to use slope and distance. So we'll use slope to show that the opposite sides are the same, making it a parallelogram, and distance to show that all the sides are the same length. A rectangle, well, that's a parallelogram with perpendicular sides. So to prove that, all we need is slope. Don't need distance at all for that. And to prove something's a square, it is a parallelogram with perpendicular sides and congruent sides. This we're going to use slope and distance. So the easiest way to do these is kind of just jump right into them and start seeing what we can and cannot prove. So the first example gives us a quadrilateral, gives us 4 coordinates, and it wants us to prove it's an isosceles trapezoid. So we have to come up with a plan. My plan is going to be to use distance to show 2 sides are congruent, and use slope to show 2 sides are parallel. Because to be a trapezoid, I have to have one set of sides that's parallel. And to be isosceles, I have to have one set of sides that's the same. So let's take a look. So if I graph 4, 7, 8, 3, 6, negative 1, and 0, 5. So it looks like from my picture, AB and CD are the parallel sides. So I'm going to start by finding the slope of AB and the slope of CD. So to find the slope of AB, I have to go down 1, 2, 3, 4 boxes to the right, 1, 2, 3, 4 boxes, which is negative 1. To go from D to C, remember we always go left to right, I'm going to go down 1, 2, 3, 4, 5, 6 boxes, and to the right, 1, 2, 3, 4, 5, 6 boxes. So those slopes are the same. Just by showing that, I can say, therefore, ABCD is a trapezoid because AB is parallel to CD. Now, to show this is isosceles trapezoid, I have to show that the distance of AD is equal to the distance of BC. So it's just distance formula twice. So from A to D, if I subtract my X values and subtract my Y values, plug that in my calculator without the square root. Remember, I'm trying to figure out what's underneath the square root. I get the square root of 20. I don't need to simplify because I'm just trying to see that they're the same. From B to C, if I subtract my X values and subtract my Y values, I also get the square root of 20. So then I can say, therefore, trapezoid ABCD is isosceles because AD is congruent to BC. Let's try another one. So next one asks, is this a parallelogram? So as you're reading this, it gives you the vertices, but it's asking you to prove something. It's asking you to prove that this shape is a parallelogram. So my plan, since it's parallelogram, is just use slope to show both sets of sides are parallel. So here's what I want you to do. I'd like you to pause the video, graph the 4 points, and see if you can find the slope of all 4 sets of sides. And then we'll come back and write the conclusion sentence together. All right, so welcome back. So here are your 4 slopes and your 4 points. So go ahead, check your work. So now that I know that these two have the same slope, QU and AD, and these two have the same slope, UA and QD, I can say, therefore, QUAD is a parallelogram because QU is parallel to DA and UA is parallel to QD. Because parallelograms have opposite sides that are parallel. Now, this is not the only way of proving this. You could have proven that the opposite sides were congruent and found 4 distances. You could have drawn in the diagonals and saw that they intersect at the same place because they bisect each other, right? So if you drew in the diagonals, they bisect at that same midpoint. All of those are good methods, but I think slope is the easiest one. So I'm always going to use slope whenever I can because you're just counting boxes. All right, let's try another one here. So it says to graph triangle FAT and prove that triangle FAT is a right triangle. We did this in lesson 6. So again, pause the video and see if you can complete this entire proof yourself. If you have to, look back at your notes from lesson 6 on how you can prove something's a right triangle. All right, so I graph my 3 points. My plan is to use slope to show that 2 of the sides are perpendicular to each other. So when I find the slope here, the slope of TA, so I'm going down, so it's going to be a negative slope. I'm going down 3, 10, and then to the right, 1, 2, 3, 4, 5, 6. So I'm going down 10 over 6. So that's going to be negative 5/3 when I reduce it. And if I find the slope of AF, I'm going to go up 3 to the right 5. So positive 3 over 5. Notice these slopes are negative reciprocals. To us, that tells us that these are perpendicular lines. So I can say, therefore, triangle FAT is right because AF is perpendicular to TA. All right, let's take a look at the second part because this is what's new. So it says, State the coordinate of point E such that quadrilateral fate is a rectangle. So what makes something a rectangle? To make something a rectangle, I know all of the sides are perpendicular. So I'm going to use a different color here just so you can see what I'm doing differently. So I already know this is a right angle. I need to make a right angle at F and at T, and E has to be someplace up here. It can't be over here because then that wouldn't spell fate. It would spell F-A-E-T. I want to spell F-A-T-E. So I want to go in order, either clockwise or counterclockwise to spell that word. So essentially, I want to duplicate the line AF from T. So from A to F, I want up 3 to the right 5. So I'm going to do the same thing, up 3 to the right 5. Here's point E. That's going to make a perpendicular line here, and it's going to make a perpendicular line here. So the coordinate of point E is 0, 6. Then it asks us to prove that this is a rectangle. To prove it's a rectangle, my plan is to use slope to show FATE is a parallelogram, because a rectangle is a special type of parallelogram. I have to prove that first. Then the second part of my plan is to also use slope to show consecutive sides are perpendicular. So essentially, I just need to find 4 slopes. I need to find the slope of AF, which I know already. I need to find the slope of TA, which I know already. I need to find the slope of FE, and I need to find the slope of EF. So looking at your picture, the slope of EF, well, FE and EF are the same, so we'll make this TE, sorry. So EF has a slope of down 10 to the right 6, which reduces to negative 5 over 3. And TE has a slope of up 3 to the right 5. So if you look, AF and TE are the same slope. TA and FE are the same slope. So you could say, therefore, fate is a parallelogram because AF is parallel to TE, they're the same, and TA is parallel to FE. So those are parallel slopes because they're the same. Now that it's a parallelogram and I notice that the consecutive sides have perpendicular slopes, I can say, therefore, FATE is a rectangle because, and just pick 2 consecutive sides. It doesn't matter which ones, because AF is perpendicular to TA. Because once you've proven one set of consecutive sides are perpendicular, they all wind up being, because you've already proven it's a parallelogram. That's why it's so important to do that first. So because a rectangle is a special type of parallelogram, I have to prove that first. So if you're proving rhombus, parallelogram, rectangle, or square, the first thing you want to do is find all 4 slopes. All right, so here's the time where you want to pause the video or come back to the video and see if you can do this homework question yourself. So go ahead, pause the video and come back. All right, so hopefully you paused the video, you tried this question on your own, so welcome back. First thing you want to do here is graph your points. And 8, 2. All right, so here's our plan. We're going to use slope to show opposite sides are parallel. So I need to find 4 slopes here. Hopefully you did this. So slope of AB, up 3 to the right 1. Slope of BC, up 1 to the right 7. Slope of CD was also 3 over 1. And the slope of AD was also 1 over 7. So I notice the opposite sides have the same slope, therefore they're parallel. So I could say, therefore, ABCD is a parallelogram because AB is parallel to CD and BC is parallel to AD. Then says, using coordinate geometry, prove it's not a rectangle. Well, we just did in a notes question to prove it is a parallelogram, that is a rectangle. We proved that the sides are perpendicular, meaning they have negative reciprocal slopes. So in this particular problem, since we've already done all the slopes, we can see that AB and BC are not perpendicular to each other. Those slopes are not negative reciprocals. So we can say it is not a rectangle because consecutive sides are not perpendicular because their slopes are not negative reciprocals. That's it. Hopefully that helped. If you're having questions, please reach out to me via email. Hopefully I see you soon.